So NPSH, net positive suction head. So whenever, especially centrifugal pump, whenever you are running, you should know the net positive suction head. Okay, NPSH formula is like this: NPSHA equals no, NPSHA greater than NPSHR. I will explain. First, write down the equation. NPSHA equals P1 by rho g minus PV by rho g plus Vs square 2g. Okay, P1 is your absolute pressure at the inlet of the pump. Vs is velocity of the fluid, in the suction pipe, this is Vs, and PV is amount of pressure required for specific liquid to stay in the liquid form, or vapor pressure stay in the liquid form. Okay. As T goes up, vapor pressure increases and decreases NPSHA. Okay. So what is NPSHA? Actually, suction. This term says net positive suction head. So pump. Let's say I have one pump. This is my suction pipe. This is my delivery pipe, right? So suction pipe, how much pressure available? A means available. Okay. If suction pressure is not sufficient, what will happen? Pump is trying to suck and pressure is not enough. So what will happen? The water, if you are pumping water, water will be vaporizing, or it will create steam actually. So that steam will not allow pump to deliver fluid, and it will try to cavitate. Cavitation, I'll explain. So cavitation means, like, if you don't have sufficient pressure, then water particle will be creating vapor. Vapor will be again collapsing. So during that process, so pump will be having violent noise. It will have lots of bubbles formation. It can fail also. Okay, so just to avoid failing of the pump, or running the pump, or delivering of the pump, you have to keep sufficient amount of inlet pressure so that pump will be running smoothly. And how to keep the sufficient amount of pressure? So let's say my water surface is here. So try to keep your pump nearby water surface so that inlet pressure will be sufficient. If your water surface is here and you are keeping pump is here, so this portion pump will be trying to suck. So when pump is sucking liquid, so pressure will be dropping actually. When pressure is dropping, so it can create evaporation and cavitation. Okay, just to avoid cavitation, you have to maintain sufficient amount of NPSH available. But how much available pressure must be there? So pump company will be delivering, or will be giving you the data called NPSH-R. Okay, NPSH-R I have written, NPSH-R. So NPSH required, Okay, who will give this one? Pump company will give. Okay, so how they will get? They will do testing of pump, and they will check how much NPSH required for their pump before cavitation starts. Okay, if they say 5 meter pressure, minimum pressure required, so actually you have to keep your pressure, positive pressure, more than 5 meter, 6, 7, 8 meter maybe you have to keep. Okay, so that's why whenever you are studying about pump, you must know about your NPSH and cavitation. If you are not maintaining NPSH, then pump will cavitate, the whole system can fail. So cavitation. So cavitation term actually you will be hearing in many places in your marine engineering systems. For example, for your propeller or one ship is moving, there also can be cavitation. Many other machinery also there. Their cavitation will be one issue for your marine machineries. Okay, so what is cavitation? So cavitation occurs when static pressure falls below vapor pressure. When static pressure falls below vapor pressure, low vapor pressure. Formation and collapsing of vapor bubbles, formation and collapsing of vapor bubbles. In a flowing liquid in a region of low pressure. Flowing liquid in a region of low pressure. Okay. So cavitation parameter or number or cavitation number sigma equals P minus PV by rho V square by 2, pressure minus vapor pressure divided by inertial pressure. So sigma less than 0, cavitation takes place. So if I write in details the cavitation formula, it will be looking like this. NPSHA, small a, capital A, you can write small a, whatever I am writing. So HP minus H vapor plus HST minus HF minus HA. So HP is absolute pressure head on surface of liquid in feed tank. Okay, and vapor pressure, absolute vapor pressure of liquid at flow condition. So all units are in feet. So NPSH also will be coming in feet. HST, static head of inlet above pump center line. This is also feet. Okay, all units must be same. HF is your friction head. I already told. Again fit. HA, acceleration head. Okay, so if fluid is having acceleration, then that head also you should include. So if you have all the data, you can calculate NPSH-A. Then if company is having, let's say, 5 meter head required and you are getting NPSH-A 4 meter, then you can say this machine is unsafe, you have to change your parameter. And if NPSH company asking 3 meter, you are getting 5 meter NPSH available, it is good. Let's say you have centrifugal pump. Okay, yes, I am using only block. or I can use simple formal notation also. This is centrifugal pump sucking fluid and it is delivering. Okay, when it is sucking, before start your pump, actually you have to fill your pump with liquid. Fill your pump with liquid before starting. Okay, so that is called priming. Okay, now you are sucking fluid from, let's say, water surface, and you assume that there will be some debris. Anything debris can come and it can block your centrifugal pump. Then what you do in that case? In that case, let's say you have one tank and you have lots of debris. Okay, so in that case you put on some valve arrangement. Okay, with some strainer. So you fill your pump. When you are filling pump, let's say initial before starting you are filling pump, but filling pump means maybe there is one hole and you are pouring from here. Okay, filling. When filling, so water will go out to the tank, right? So how to prevent? So just before entry of the, just after entry of the pump at the suction pipe, okay, so there will be one valve or foot valve. Okay, so this is one way valve. When you're filling it, so water will not go back to your tank. Okay, when pump will be starting sucking, so valve will be opening, it will allow fluid to enter into the pump. But when you are filling from the top, it will not allow. So when you take one bucket, you fill the pump, one bucket, two bucket, three bucket, up to three bucket, whole pump will be filled. Now you close the filling channel or knob will be there, so just close it. Now start your pump. When you are starting, valve will be opening and fluid, it will allow fluid to suck from there. So this is called foot valve. Okay, so many pump will be requiring that foot valve during initial starting. Okay, so we have already seen that HP equals rho Q H 3960 eta. Eta, this is overall efficiency eta. Eta overall efficiency, and H 3960 H in feet and Q in cubic feet per second, and LB pound by cubic feet. Okay, horsepower requirement. So water horsepower, water HP divided by electric horsepower. How much electricity you are giving? Electric HP. Okay, and power in watt? Equals rho Q H G by eta, efficiency, and rho meter cube, Q meter cube per second, rho kg per meter cube, rho kg per meter cube, G 9.81 meter per second square, and H meter. So let's say pump is here, you are delivering here, you are sucking from here. So your total head will be water level to this. This is delivery head, I already told. Delivery, this is suction. So overall efficiency eta equals water power by shaft power. Rho Q H by P. So impeller diameter and head relationship, H equals eta U square by 2G. Okay, so head by a pump, centrifugal pump. Okay, H equals this one. So eta is impeller efficiency or pump efficiency. Pump efficiency, u equals impeller velocity, impeller speed. So impeller speed equals omega into r. Again omega equals 2n pi by 60 into r. N is your RPM, revolution per minute. Okay, so normally we assume 60 to 70% eta. Okay, if number of stages n of stages equals small n, then total head by n stages equals nh. Okay, h already you have calculated. You can see left side head by a pump. Let's say simple problem. If a pump delivers water 100 feet, 100 meter, it is delivering water 100 meter centrifugal pump. If a centrifugal pump delivering 100 meter head and impeller diameter 6 inch, efficiency 70%, n equals 1400 RPM. Instead of d 6 inch, we can write in meter, maybe 0.2 meter. Okay, then how many stages will be required? So in that case, what we can do, omega equals 2 into n pi by 60 equals 2 into 1400 into pi by 60. We can calculate. Okay, I am not calculating, I am leaving for you. So h equals eta means 70, 0.7 into u square, u means omega into r, omega into r square by 2 into 9.81 equals 0.7 into omega. I am already getting here, r value d is there, so r will be 0.1 meter. So you can put the values, okay, then you calculate. Very simple problem, I hope you can solve it.